Welcome again to this Europractice webinar series. My name is Maria Martinez Balado. I am a program manager at IMEC and Europractice, and I will be your host during this whole webinar series that we start today. The topic of this webinar series is very special because it's all about Pragmatic and its flexible integrated circuits, and it consists of 2 episodes. So today, Dr. Francesca Bottacchi will tell us about Pragmatic and its flexible integrated circuits technology and explain the advantages compared to, for instance, more traditional silicon technologies. Then next week, we will have Adil Masood and Suman Balaji, who will go a bit more into details of the technology. Then they will show some details of the PDK as well, and will explain us how to access this technology and how we can fabricate our chips through the service offered via Europractice. So now it's time for me to introduce our speaker. Francesca Bottacchi got her PhD in experimental solid physics at Imperial College London, working in organic optoelectronics devices, and she has 10 years of experience in flexible electronics. In 2016, she joined FlexEnable, where she supported the technical development of organic backplanes for flexible LCD displays. And as for 2022, she joined Pragmatic as the account manager for Foundry Business, and she spends her days working both with academics and industrial customers as the main commercial contact. So having said this, is for me the time to give the floor to Francesca. So yeah, Francesca, we are all looking forward to your presentation, and I hope you all enjoy it.
Thank you very much, Maria, and good morning, everyone. I will share my presentation. Okay, good. So as said, today I will focus on introduction to Pragmatic's flexible integrated circuits, which we call FlexIC. The content of this webinar will start with a brief introduction of flexible electronics and flexible integrated circuits and what are the main differences. Then I will briefly talk about some new applications enabled by flexible integrated circuits. I will then give a quick overview of Pragmatic, and then I will dive into the advantages of FlexIC, applications that we are really focusing at Pragmatic with FlexIC, and why you should choose Pragmatic as a technology. So flexible electronics. When you think of flexible electronics, the first thing that usually comes to one's mind is that it's usually low cost, it's a large area, and it's normally compatible with roll-to-roll manufacturing, and very often is also printed, And this can be printed, for example, on flexible substrate or even on paper substrate to be even more sustainable. It is particularly used in the photovoltaic industry for displays, either liquid crystal displays or even OLED displays. And more recently is also very used for wearable applications. Often, flexible electronics can also be used in conjunction with conventional silicon electronics. So very often, especially in the wearable application for healthcare, it's very often you can find a flexible substrate with metal tracks and electrodes, to be like with an adhesive to be conformable on the patient skin. But then the intelligence and the chip very often is still provided by a silicon chip. So it's still using a conventional and rigid component. What is instead a flexible integrated circuit? So flexible integrated circuits is still part of flexible electronics, of course, but with some peculiarities. So the easiest way to describe a flexible integrated circuit is as an equivalent of a silicon ASIC, but cheaper and flexible. So it's not small. It's small area, so it's not large area. It's small area, and it's not printed, and it's not compatible with roll-to-roll manufacturing. So these are some main differences, between flexible integrated circuits and flexible electronics. And this is because it uses conventional semiconductor equipment that are based on wafer processes and mainly using photolithography. But the biggest advantage is that its use is suitable for analog, digital, and mixed signal. So you can really reproduce the circuit that you design on a silicon ASIC. You can really reproduce it using a flexible integrated circuit. Some of the let's say newest applications that can be enabled by flexible IC combined also with the flexible electronics are, for example, in the microfluidic sector, on a lab on a chip device, you could add a flexible IC to increase the functionalities of your microfluidic device and add some intelligence to it. You can embed a smart NFC tag into a plastic package to increase connectivity of every item, for example. And then, of course, we already talked about wearable devices for the healthcare sector. You could really go fully flexible. Even in this example, you can see that the device is still a rigid component, but with the flexible integrated circuits, you could really go into a fully flexible form factor, which is more comfortable for the patient and more user friendly. And then also e-textile is a very hot topic recently. You could embed really your chip into every single fiber and into all fabrics to really add functionalities of your products. So let's concentrate on healthcare. Healthcare is a really important sector for us. And is also a very good fit for flexible integrated circuits. So if you think of logistic, for example, you could embed a flexible NFC tag into a vaccine vial or a blood sample, for example, and you can really use that to track all the status of your medical product. From the origin to check the provenance to the end, to the hospital, and really down to when it's administered to the patient. You can check the status of the product during the whole transport. For example, if the vaccine requires to be stored at a certain temperature, you can make sure that the cold chain was maintained during transportation, and you can use it or enhance checks on the quality and on the expiry. Of course, you could do this also using conventional silicon, but the cost of it would not be sustainable for the hospitals and for the national system. Another example is a smart bandage, for example. You could again add integrate an NFC tag with some sensing functionalities into the same circuit, and you could monitor the status of a wound by, for example, adding a moisture sensor and really check that the status of the wound without having to remove the bandage every day. And you can really inquiry your smart bandage with your phone, using an app, and check the percentage healing of the wound, and really make sure that you remove the bandage only when the wound is 100% healed. Another example is a smart patch, for example, where you can design a circuit that can detect, for example, an anomaly in your heartbeat. And again, integrated with an NFC, you can use this to detect anomaly. And again, with your smartphone, with an app, you can really send, the device could send an alarm, or there could be an LED blinking or a sound that can really give a warning to the user to go to the hospital for further checks, for example. And finally, can also be used for active treating. You can design, for example, a controller and a timer, and you can use that to release a certain amount of drug at a specific interval of time. To really treat a patient at home, but in a very controlled way. All of these applications, in principle, could also be done with silicon, but the main difference is that most of them are consumable, and some of them can even be disposable. And so when you think about, using one of these products only maybe for a very limited period of time, or like a single time use, then really silicon it's not affordable from a cost point of view for the healthcare system. And the form factor is also plays an important role. This needs to be comfortable and very user-friendly for the patient to be so that it can be worn for a continuous amount of time. So let's now talk a little bit of Pragmatic. What do we do? So Pragmatic, we manufacture flexible integrated circuits that we call FlexIC. So this is an example of one of our wafer. The whole manufacturing is done on a rigid glass carrier, but at the end of the process, the wafer is released from the glass, and this is the final form factor that you see is extremely flexible and also semi-transparent. Pragmatic was founded in 2010. In Cambridge, in the UK. Currently, we are 240 staff, but we are rapidly growing. So every week, someone new is joining us. We received $180 million dollar funding to date. And you can see some of our major investors here. The most strategic from a technical point of view are ARM, Avery Dennison, and Amcor. Our headquarters is in Cambridge, where all the IC design, sales, marketing, and finance are located. And in Durham, in the northeast of England, we have the manufacturing facility where, of course, the operation and the test team are based. So at Pragmatic, we make flexible integrated circuits. And this technology has 6 main advantages, I would say. First of all, it's low cost. It's inherently low cost because of the materials that we are using. It's non-silicon based, so there's no silicon anywhere in the process. So because of the material we use and because of the process that we use, it's inherently low cost. And because of the process we use, again, is also low carbon impact. So it's a more sustainable manufacturing process. It's ultra thin and flexible. The wafer that I showed you before, it's 30 micron thick. So that's the thickness of the wafer, and it's extremely flexible down to 5 millimeter of bending radius. And so these two advantages, of course, enable a whole new set of application and use cases. And then there's also the added advantage of being extremely fast. Our turnaround from tape out to delivery of the parts is around 6 weeks. So it's just a few weeks time. And this again is possible because the process are really optimized. There's the manufacturing is it's less energy intensive. There's less steps involved. There's less materials involved. So everything is really is much quicker and easier to manufacture. And then, of course, being on plastic, being basically based on plastic, it's extremely shock resistant, so it's not brittle like silicon, and it doesn't crack as easily as silicon. So again, it can be used for some new applications. So let's now talk a little bit about IC design. So it takes really a lot of time to design an IC chip, especially if it's a completely new circuit. And one of the biggest challenge for IC designer is really to do it first time right, especially when you are using the latest tech node, which are extremely expensive and they have a very long turnaround. Then you really you cannot afford any mistake. So it really needs to be a perfect design from the first time. And this is a big challenge, and it's really resource intensive. With FlexIC and with our technology, because it's low cost and because it's so fast to get the wafers back, you can really change the way of designing, and you can really use an agile design approach. Most of our customers, they plan for even 4 or 5 tape-outs every year. And by doing this, you can really design and test and optimize and design and test and re-optimize and really improving your design by having multiple quick design iterations. And this could be a big advantage for many designers. Sometimes it can also be that you need to design a whole PCB system, you know, an whole electronic system with multiple components, with your silicon ASIC and multiple components on a PCB. And this can also be really time-consuming and really complex. So another way that we can help is by really shrinking the design and move all the additional components from the PCB. You can really design them into a FlexIC. So, you know, if you think of the conventional rigid PCB, you have all these rigid components. And nowadays, it's also very common to use a flex PCB, but still with a lot of rigid components onto it. Our vision is really to go fully flexible, and you can remove all the external components and really design them into a FlexIC. And this would not be affordable with silicon because, you know, you cannot, it would not be cost effective to tape out a silicon chip only for some capacitors and resistors. But with FlexIC, because it's so low cost and quick, this is actually a really good fit for our technology, where, you know, you can replace all the surface mount devices and really design them into an integrated passive device solution, where all your passive devices are all inside a FlexIC. And you can still have your silicon ASIC if the performance requirements are very high, or you can even replace your silicon ASIC with, again, a FlexIC and having 2 separate FlexIC, one for performance and one for the passive devices, or you can even combine both in a single big chip that does both. And in this way, you can, of course, reduce a lot of the cost, the footprint, you know, you can shrink the footprint of your PCB, and in general, you can reduce the complexity of your system. So still talking about IC design, with FlexIC, we are really trying to enable a fit-for-purpose IC design approach. There's really a need in the current moment. There is really a need to design fit-for-purpose IC on legacy node, but the problem is that there's no capacity for it. All recent investment usually are made in the most advanced tech node, where you want to get performance at any cost. And there's no room for a fit-for-purpose IC, where the performance requirements are not that high, But there's still so many applications that you can enable with, dimensions between 0.6 to 0.18. It's really a sweet spot for our technology, and that's where we really focus. We are really focusing, and we are really enabling this fit for purpose IC. And some example of circuits and applications that you can enable with this range of design is, for example, again, the healthcare, where being with the flexibility and the thinness and the plastic material, you can really improve the form factor of the device. You can go from a shared electronic appliances that is really expensive and you need to go to your doctor to get the measurement done, to the current generation of rigid wearables, but it's still quite expensive to be deployed to a wider community, and really going down to an ultra thin smart patch for continuous monitoring that, in our vision, this should be extremely cheap, very comfortable, and provide, of course, the same performance as the previous, but in a more also sustainable, product that can be also easily be disposed. Another example is in the biometrics, for the biometrics application. Credit cards, nowadays, they're all contactless. You can enable a transaction up to a certain value with contactless, but above that, you need to enter a PIN or a password or a physical signature. And, everyone hates PINs and passwords. 21% of us forget a password after 2 weeks, and 25% of us even, forget a password, one password every day. So it's both the consumer and also the banking system. We all acknowledge that we need to move away from PIN and password. And one solution is, for example, to use a fingerprint sensor, which is extremely secure. It protects data and doesn't have any transaction limit. You can, enable the transaction with your finger. This can be done, of course, with silicon technology, but there are two main problems to it. First is the mechanical requirements. A credit card, it's not as flexible as a plastic packaging, of course, but can still be bent. And you could, for example, put it in your pocket and you can sit on it. So, of course, the chip needs to withstand a certain pressure and stress. And also the fact that the chip is quite large. With silicon, it will easily crack. Another problem is the cost. You cannot shrink your finger. So even if you use the latest tech node and your design, you shrink your design to the minimum footprint required, you still need to account for a certain footprint that is the one of your finger. You still need to put your finger onto your circuit. And this, if you do it in silicon, would be unaffordable, would be more expensive than the actual card. So this is not sustainable, of course. But with the FlexIC, this is a perfect fit where, the low cost, the inherently low cost technology and the flexibility of the chip, which is even more flexible than the card itself, makes it a really perfect fit for this technology. Another example is of course, connectivity. This is a field where we are really focusing a lot in Pragmatic, to develop RFID and NFC tags, because we think that with the low cost of this technology and the flexibility, we can enable, connectivity between every object, really, even the lowest cost coffee cup or plastic bottles that can be embedded with a tag, and they can connect with the external world. So some examples of topics, let's say, that you can enable with the NFC type of connectivity that we are working on are these four. For example, if you think about sustainability, you could add an NFC tag to a plastic bottles and a reader into your bin. And you can make sure that the correct item is disposed in the correct bin, and the bin opens only if it detects the correct signal from the correct item. And in this way, of course, you can increase correct recyclability of the item. You can implement deposit return scheme where now you get a reward if you dispose correctly of your item. And this is something that we're also working with local councils, for example. And then for the authenticity, you can add a tag to make sure that your item is authentic, is not being tampered with, to reduce anti-counterfeiting and to prevent the gray market. And of course, for tax and duty confirmation, you can make sure that your item is really genuine. And then for traceability, that's what we already discussed with the healthcare sector, but you can really apply this to any sector in terms of quality control, product recall and expiry, optimize stock control and supply chain. And you can really improve the whole traceability of your product during the whole logistic journey. And then interactivity, you can increase consumer engagement and connect physical to digital and implement loyalty scheme and really add some extra functionalities to your products. But you can also go farther. Not just an NFC tag, but you can add, for example, some sensing capability. You can add a temperature sensor, a humidity sensor, or even some gas sensor, like CO2 sensor, for example. Can all be integrated into the same circuit with the FlexIC. And you can use this to give insight into the provenance of a product, of a food in this case, its quality and its packing condition. 30% of food is currently wasted, and 40% of the waste occurs at the retailers and the consumer. So there's a huge amount of food that is wasted simply because the use by date tell us that the food is not good anymore, even though the food might be perfectly safe to be consumed. And so by adding a real-time sensor inside of the package, you could really inquire and check the status of your food and, for example, use it for dynamic pricing and dynamic use by date to make sure that the use by date really reflects the status of the food. And this can be used to massively reduce food waste at home and also in retail. So this is to conclude a little bit the section on the applications. This is to give some example of what we've achieved in terms of publication at Pragmatic. In 2021, this was probably the most famous publication. This is the plastic arm that was published in Nature, and it was done in a collaboration with ARM, where basically ARM engineer, they designed the circuit, but Pragmatic did the manufacturing of the wafers. And in this case, we reproduced a Cortex-M CPU with 32 bits of data and 56,000 devices. And this was done on a 0.8 micron channel. So, even with a very low tech, you can still achieve really, high performing circuits. And more recently, we've also published some results on a electronic nose sensor and SAR ADC DAC for on-body sensing, which is a very important interface. If you want to, it's a very important circuit if you want to interface with a sensor. For example, if you want to interface an NFC tag with a sensor, you really need this circuit. So let's spend the last probably 10 minutes on some wider semiconductor discussion. So recently everyone is talking about some of the the semiconductor industry. You can hear in the news talking about it very often. And so these are the three probably biggest challenge of this industry. And so I just want to tell you what are we doing at Pragmatic to try to help. So the first problem is the broken supply chain, especially after COVID. All the governments and everyone realized that 65% of the global supplies is in Asia, and everyone realized that this is not really a good idea. It's not sustainable, going forward. And there's a big mismatch between demand and supply. From a geopolitical point of view, Taiwan, it's very strategic, but there's also a lot of uncertainty around what will happen with that. And Western governments are really investing heavily to onshore semiconductor manufacturing. We've seen recently with the US Chip Act, the UK semiconductor strategy, and hopefully very soon with the EU Chip Act. So every nation, every country is really trying to get some sovereign capability of semiconductor manufacturing. And then, of course, we have the sustainability problem. Silicon manufacturing is really non-sustainable, especially also because the volumes will only increase in the future. So we will get even less and less, sustainable. So there's a lot of ESG pressure on the supply chain, and also a lot of pressure to improve the traceability of supply chain for semiconductors. And all governments and companies are really investing heavily to achieve a net carbon zero. So what are we doing at Pragmatic? So Pragmatic, this is a picture of our first manufacturing line. It's a 200 millimeter wafer fab. So it's an 8-inch wafer fab installed within 200 square meter of an existing clean room. So this is extremely compact. 200 square meter is really, really small if you think of semiconductor manufacturing. And it is enclosed in a box, and it's fully automated, and it requires minimal engineering maintenance. This is currently used both for commercial orders and also for R&D development. And we also have a new line, a 300 millimeter, so it's a 12-inch volume line that will be launched next year in 2024, and this will be dedicated only to volume production. So the advantage of this manufacturing, this line, is that it's extremely compact and can be deployed anywhere. So one thing that we are also offering, so in addition of manufacturing wafers, we can also basically provide a fab as a service. And so we can enable every country to have some sovereign capability of semiconductor manufacturing. Every region, if you have a local need for some semiconductor manufacturing because of a special ecosystem, you can have a semiconductor fab in a specific region, or even inside an existing factory. Being so small and also affordable compared to silicon, even a strategic and critical industry can buy a fab and place it inside of their own factory to have a secure and controllable supply chain. For sustainability, instead, we are also, let's say, proud to consider ourselves as a greener semiconductor manufacturing in our process, because it's because of the materials and the process steps that we use. We are using less gases and chemicals, and also safer gases and chemicals. So they're easier to dispose, and there's no need for special treatment processes. We are using less water, so there's a lower water consumption, and the temperature required are also lower. So in general, the energy requirement is much less. And this, of course, has an effect on the carbon footprint that we produce. So with this, I would like to conclude on why you should choose Pragmatic. Pragmatic, we are, world leader and low-cost manufacturer of thin-film flexible integrated circuits. We are a more sustainable alternative to silicon. Our turnaround is extremely fast, and within a few weeks from tape out, you can get your wafers or your parts delivered to you. Our PDK is ready to use and is compatible with all major EDA tools. And because of the form factor and the low cost, we can enable really a whole set of new applications and bring intelligence to every low-cost item. So by using our Foundry service, you can get multiple, fast, and affordable tapeouts with ready-to-use PDK. So with this, I conclude, and I just want to mention that next week there will be the second webinar of this series where Adil and Suman will go into the technical details of the technology and how to access the MPW service from EuroPractice. And then also a final announcement that there's an upcoming training event that will be done in person in IMEC in December. And this will also be on flexible integrated circuits from Pragmatic. So thank you very much for your attention, and I'm open to questions.